Hello, my dear students. A very good evening to all of you. My name is Mohammed Ehtisham Siddiqui. I teaches you on India's largest online live learning platform, that is Unacademy's YouTube channel. Let's crack GATE and ESE Civil. So, in this session, we are discussing about GATE 2021 solution. Already, we have discussed the two sessions, that is the water resource engineering sessions. One is for the forenoon session and one is for the afternoon session. If you want to see those sessions, you can go in the description box or you can go in the playlist available in our channel. So moving forward, we in this session we are going to solve the geotechnical engineering questions which are coming in the GATE 2021. Okay, so we are going to solve such type of question. Very good evening, Abhishek Verma. And let's check that how many questions you have attempted rightly. So my name is Mohammed Ehtisham Siddiqui. My name is Mohammed Ehtisham Siddiqui. I am an alumni of JMI New Delhi, 4 times GATE qualified, 3.5 years of teaching experience, taught more than 10,000 students all over the India, guided students who secured AIR rank in different examinations. And these are the list of the subjects which I used to write. Roshan Pandey, very good evening. Okay, so in this session, what we are going to discuss, in this session, we are discuss about the GATE 2021 solutions for the forenoon sessions for a subject that is called as geotechnical engineering. So let's start. This is the first question which have came in the GATE 2021 examination. It's one of the easiest question which have came in 2 marks. Similar question have come in the past year also, but the diagram was little different. This is the most easiest question which can come in the GATE examination in the geotechnical engineering. So the questions, there are two reservoirs which are connected through a homogeneous and isotropic aquifer having hydraulic conductivity this and the porosity is this as shown in the figure. Groundwater is flowing in the aquifer at the steady rate. Okay, so what the given, that upstream depth is given, downstream depth is given. So water will flow from through this aquifer. The water can't be flow in aquiculate. The water cannot be flow in the impervious layer. So the water will flow in the aquifer in this direction. How the water flow? Water will always flow in this direction along the slope, and it is perpendicular to the direction of flow, and this area is nothing called as area of cross section. Okay, moving forward, if the water in the reservoir 1 is contaminated, then the time in days taken by the contaminated water to reach to the reservoir 2. So what he is trying to say, if we release a contaminant at the reservoir 1, then how many days it will take to reach the point B or to reach the reservoir 2. So we have to know that what is the time taken by the particle or by the contaminant. As we know, the contaminant will move through the voids of the soil because the contaminant is just like a tracer. So it will move through the voids of the aquifer, and as we know, the velocity of the water which is flowing through the voids is called a seepage velocity. It means the velocity of that particle, the velocity of that contaminant will also be seepage velocity. So as we know, the velocity of contaminant is equal to seepage velocity. So as you know that speed is equal to distance covered divided by time. As you are clearly seeing, the distance covered by the tracer is 2000 meter, and the seepage velocity or the velocity of Vs cannot be known. So if I are able to find this Vs, I can able to find this time t. And as we know that the seepage velocity depends upon the discharge velocity, I can write that the seepage velocity is equal to discharge velocity divided by porosity, and discharge velocity is equal to permeability of soil multiplied by the hydraulic gradient divided by porosity. And how you will calculate the hydraulic gradient? Hydraulic gradient is equal to the head loss. So how much will be the head loss? When the water will flow from this end to this end, how much will be the head loss? The head loss will be equal to the amount of head which is available. So the amount of head which is available is nothing, that will be equal to 20 meter. And how much length it will lost, as the water will flow along 2000 kilometer, 200 kilometer, sorry, 2 kilometer. So it means the length of flow is 2000 meter. So this meter will be cancelled out by this. So the hydraulic gradient will comes out to be 1 by 100. Hydraulic gradient will comes out to be 1 by 100. You're getting? So from this, from here we can find seepage velocity is, permeability is 25 meter per day, 25 meter per day, multiplied by hydraulic gradient is 1 by 100, and the porosity is equal to 0.3. So the seepage velocity will comes out to be 25 divided by 30 meter per day, divided by 30 meter per day. 5 5 is 25, 5 6 is 30. So it means the seepage velocity comes out to be 5 by 6 meter per day. Yes, 5 by 6 meter per. So this is nothing but the seepage velocity, but you don't have to find the seepage velocity. What we need to find? What we need to find the time which is required. So on putting the value in equation 1, if we put the value in equation 1, then the T comes out to be 2000 divided by 5 multiplied by 6. 5 4s are 20, 0 0. So then that would comes out to be 2400 days. So the time which is required by a contaminant to reach from the reservoir 1 to the reservoir 2 is none other than 2400 days. I hope you understand the solution, that 2400 days will be required for a tracer, for a contaminant to reach from the reservoir 1 to the reservoir 2. I hope you understand the solution. It's a very easy question which came in the GATE examination. This such type of question can also become in the mains examination also. So moving forward to the next question. This is a very beautiful question. Let's see how many students will tell me the right answer of this question. There are 4 options, 1 2 3 4. Tell me what is the right option of the question. Everyone has to be answered. आंसर करके बताइए. क्या आंसर आएगा? लेट्स सी कितने बच्चे इसका आंसर बताते हैं. है ना, अच्छा सवाल है. देखिए कितने बच्चे इसका आंसर बताते हैं. लेट्स सी, जल्दी से आंसर करके बताइए बेटा, जल्दी से आंसर करके बताइए. देखिए सवाल क्या है, इट्स ए वेरी गुड क्वेश्चन, है ना. बहुत सारे बच्चे इस क्वेश्चन को गलत कर देंगे, लेकिन अच्छा सवाल है. देखिए कह रहा है, in a odometer apparatus, as we know that in order to check the compressibility of a clay, we do a test that is called as odometer test or consolidometer test. So in a odometer test, a specimen of fully saturated clay has been consolidated under a pressure of 50 kilonewton per meter square and is presently at equilibrium. The effective stress and pore water pressure immediately on increasing the vertical stress to 150 kilonewton per meter square respectively are. What he is saying, just listen this thing, that just listen one thing, that what we do in odometer test, in the odometer test we do the increment of the loading. हम धीरे धीरे लोड को बढ़ाते हैं. Slowly we'll increase the load. So initially the load is applied as 50 kilonewton per meter square. How much load is applied? 50 kilometer per meter square load is applied, and this sample is allowed to consolidate. And after jab sample will start consolidating, then the volume of the sample will start decreasing. The length or the thickness of the sample will start decreasing. But when as soon as you applied 50, then at excess pore water pressure will develop, and that excess pore water pressure slowly dissipate, water will comes out, and slowly after some time the thickness or the sample will come in equilibrium. So as he is saying that the soil is consolidated, as he is saying the soil is consolidated, so when you had applied this 50 kilonewton per meter square, then all the load was taken by water, and excess pore water pressure had dissipated, excess pore water pressure had developed. But since you have consolidated this soil sample, so this excess pore water pressure will dissipated with time and the sample of the thickness will decreases. So soon as the excess pore water pressure will dissipated, the effective stress will keep on increasing, and T is equal to infinity. When the sample will come in equilibrium, then all of the loading which is taken by the water, that is the excess pore water pressure, will get converted into effective stress. It means that when the sample is in equilibrium, then the effective stress, then at this instant the effective stress in the sample is 50, and excess pore water pressure it at this instant is nothing but 0. Now read it. What he is saying now, what is the effective stress and pore water pressure immediately? Matlab at T is equal to 0, on increasing the vertical stress 2. It is not saying on increasing the stress by. इतना बढ़ा दिया, ये नहीं बोल रहा है, ये बोल रहा है इतने तक बढ़ा दिया। तो इसका मतलब है कि 50 लग रहा था, अगर 150 कर दिया तो इसका मतलब आपने बाहर से कितना लगाया होगा? बाहर से यू हैव अप्लाइड कितना? 100 किलोन्यूटन पर मीटर स्क्वायर. दैट्स व्हाई द टोटल वुड कम्स आउट टू बी 150 kilonewton per meter square. Now he is saying immediately tell me the effective stress and pore water pressure. As you say, as you know, as you applied the load, so all of the load will be taken by the water. All of the load will be taken by the water, and the excess pore water pressure will develop at T is equal to 0. At T is equal to 0, if I talk about the excess pore water pressure, so all of the load was taken by the water, so the excess pore water pressure was 100 kilonewton per meter square. And if I ask about the effective stress, since all the loading is taken by the water, so at T is equal to 0, effective stress will not increase. So the effective stress will be the same which is available in the soil sample. So at T is equal to 0, after the application of 100, that is total 150 kilonewton per meter square, the excess pore water pressure is 100 and effective stress is 50, and he is asking first effective stress is 50 and excess pore water pressure is 100. So the correct answer of this question would be 2. Most of the students have done this question wrongly, but this is second option is correct option. So I hope you are understanding, and this is a very beautiful question which have came in the GATE examinations. Okay, so moving forward, all the students kindly like the video, share the video, and just tell all your friends about this session. Moving forward to the next question, it is a very easy question. Just read it, this question. What he's trying to say, he is saying a partially saturated soil sample has a natural water content of this and bulk unit weight of this. The specific gravity of solids is this and unit weight of water is this. So what he is saying, the unit weight of the soil sample on the full saturation, matlab you need to find the saturated unit weight. As you know, gamma D is equal to gamma T divided by 1 plus water content. Gamma T is nothing but is equal to 18.5, and water content is nothing, is equal to 1.25, is equal to GS gamma W divided by 1 plus C. I can also write gamma D is equal to GS gamma W upon 1 plus C. So 18.5 divided by 1.25 is equal to GS 2.65. Gamma W is 9.81 divided by 1 plus C. On solving, the void ratio will comes out to be, on solving, bacha log, the void ratio, I am just telling the what is the value of void ratio. On solving, bacha, the void ratio comes out to be 0.756. Now you need to calculate the value of gamma set. So gamma set would comes out to be, so S is equal to 1, GS plus E upon 1 plus E multiplied by gamma W. GS is 2.65, E is 0.756 divided by 1 plus 0.756 and multiplied by 9.81. On solving this, multiplied by 9.81, on solving this, gamma set comes out to be 19.036 ऐसी कुछ वैल्यू आ रही है किलो न्यूटन पर मीटर क्यूब. सी द मोस्ट अप्रोप्रिएट ऑप्शन. The most appropriate option is nothing but the fourth option, that is 19.03. So I hope you have completed or you have done this beautiful and easy question in your examination. It's a very easy question. Moving forward to around 7 to 8 questions have come in the forenoon session, and all the questions are very even extremely easy questions. Okay, so next question, direct formula based question. Just see this. A tube well of 20 centimeter diameter fully penetrates a horizontal, homogeneous, isotropic, confined aquifer of infinite horizontal extent. Okay, the aquifer is 30-meter uniform thickness. A steady pumping at a rate of 40 liters per second from the well for a long time results in a steady drawdown of 4 meter at the well face. The subsurface flow to the well due to pumping is steady, horizontal and Darcian, and the radius of influence of the well is 245. The hydraulic conductivity of the aquifer. So it's a very easy question. You can easily solve this. Suppose this is the ground surface. Suppose this is the ground surface and this is nothing, and this is nothing but the aquifer. Suppose this is the ground surface and suppose this is nothing but the confined aquifer. Suppose this is nothing but the confined aquifer. So what you do in the confined aquifer case, you penetrate your well to the entire thickness. You penetrate your well to the entire thickness. So this is basically the confined aquifer. Okay, and you have penetrated this well. The thickness of confined aquifer is denoted by D. The thickness of confined aquifer is denoted by D. The thickness of confined aquifer is denoted by D. And he is saying a steady discharge is taken out and it is equal to 40 liter per second. A steady discharge is taken out and it is equal to 40 liter per second. When the steady discharge is taken out, the drawdown in the main well, means this value, the drawdown in the main well, that is called as SW, is given as 4 meter. And the radius of influence, what do you mean by radius of influence? It is the distance beyond which drawdown cannot be seen. And this drawdown value comes out to be, comes out to be given as 245. And this distance from bottom to the top is nothing is equal to h naught. That is equal to h naught. And the radius of influence from the center of well is r. It is given. And as you know that the formula to determine the permeability, मैंने already आपको, I have told you to write this or remember this formula in the form of Q. Q is equal to pi kd. Q is equal to 2 pi kd H2 minus H1 divided by log of base E R2 by R1. Since here the observation wells are not given, so one reading you will take at the main well and another reading you will take at radius of influence. So the formula would becomes 2 pi kd. The formula will becomes 2 pi kd. When the rate r is equal to radius of influence, then the height of water is equal to h naught. When the r is equal to rw, then the height of water in the well is nothing is equal to hw. That is equal to minus hw divided by log of base E, cap R2 is equal to R and R1 is equal to RW. And as you see, H0 minus HW is nothing but equal to SW. So I can also write this formula like 2 pi kd into SW divided by log of base E R upon RW. You're getting my point? I hope you're getting my point. So from here you can determine K is equal to Q, and Q is given as 40 liter per second, that is equal to 0.04 meter cube per second multiplied by log of base E R. Log of base E R, radius of influence is 245 and the radius of main well is 0.1 meter divided by 2 pi multiplied by d. D is nothing but the thickness of aquifer, and it is given as 30 meter. So you will get the answer in meter per second, but it is said that you have to answer it into meter per day. E, just multiply the whole values by say 86,400. You will get the answer. You will get the answer in meter per day. Tell me what is the value which is coming. Jaldi se solve kariye and tell me what is the value which is coming. Tell me what is the value which is coming. 2 पाई के डी, तो यहां से के की वैल्यू हो जाएगी के इज इक्वल टू दिस, ओके, डिस्चार्ज इनटू दिस डिवाइडेड बाय 2 पाई के डी. ओके, एस डब्ल्यू इज ऑल्सो लेफ्ट. एस डब्ल्यू इज नथिंग, दैट इज इक्वल टू drawdown is given as 4 meter. So when you put this at 4 meter, so value is coming out to be 35.77 meter per day, and he is saying you have to answer it in nearest integer value. So what answer you are gonna to report, because you have to put the answer in integer, so the value will comes out to be 36. So if you put the value is to be 36, then you will get the full marks. But if you have put the value in points, then you will get 0 marks. Then you will get 0 marks. You will get 0 marks. I hope. MD Khan, dashing look. Thank you so much, MD Khan. Okay, चलिए moving forward. बेटा पढ़ाई पे ध्यान दे दीजिए. नेक्स्ट क्वेश्चन की तरफ बढ़ रहे हैं. It is also a very easy question which have came in the GATE examination. Just read this question. Very easy question. An unsupported slope of height 15 meter is shown in the figure, in which the slope faces at 50 degree with the horizontal. The slope material comprises purely cohesive soil having undrained shear strength. So the undrained shear strength is given as 75 kilopascal. Very good. A trial slip surface KLM with radius 25 meter passes through the crust of the toe of the slope, and it subtends an angle of 60 degree at the center. The weight of the active soil mass is 2500 km per meter cube, which is acting at a distance of 10 meter from the toe of the slope. Consider the water table to be present at higher depth from the ground. Then, considering the trial depth to be KLM, the factor of safety against the failure of under undrained condition, round off to the 2 decimal places. As we know, factor of safety is nothing. Factor of safety is nothing is equal to resisting force. यहाँ पर we will discuss, because the soil will move or the soil will fail due to rotation. So we will write the factor of safety is equal to resisting moment divided by overturning moment. So what is resisting moment? The thing which resists, nothing. The thing which resists is nothing but the shear strength of soil, and it will act along this slip surface. It will act along this slip surface like this. So if I talk about the resisting moment, so it will be resisting force. It will be resisting force multiplied by the lever arm. So resisting force is nothing, that is equal to Cu multiplied by the length of this arc, multiplied by inside length 1. I am treating the inside length as 1, and multiplied by the radius is nothing but 25. So moment of resistance, that is called as resisting moment, comes out to be 75. Arc angle is equal to arc upon radius. So arc will be is equal to 60 degree multiplied by radius r. So it will comes out to be 60 multiplied by pi by 180 multiplied by radius is 25 multiplied by the 25. So you will get the value of moment of resistance or resisting moment. Similarly, if I talk about the overturning moment, so this weight will tries to overturn it. this weight component will tries to overturn it, and it comes out to be the weight multiplied by this lever arm distance thus. So is it given the weight of the, is it given the weight of the active soil is 2500 kilonewton per meter. So you will write like this, is you will write like this 2500 kilonewton per meter multiplied by inside length 1 or multiplied by 10. So what you have found the resisting moment, overturning moment, just substitute it in the previous equation. So the resisting moment is nothing that is equal to 25. If I cancel it, this comes out to be 3 and it comes out to be 25. 25 into 25 into 25, 25 ka cube multiplied by pi divided by 2500 multiplied by 100. Solve it and tell me the right answer of the factor of safety. Solve it and tell me the right answer of the factor of safety. Solve it and tell me the right answer of factor of safety. The value will comes out to be 1.9625. You have to answer it two decimal places, so you can write it to be 1.96. The answer would comes out to be 1.9625 is the factor of safety against rotational failure. I hope you understand. Moving forward, it is also a very easy, extremely easy question है ना. अगर आपने थोड़ा सा भी पढ़ा होगा बेटा स्टेबिलिटी ऑफ स्लोप तो आप इसको कर सकते हैं. नेक्स्ट क्वेश्चन, इट इज ऑल्सो ए वेरी ब्यूटीफुल क्वेश्चन. जस्ट ट्राई टू सॉल्व दिस क्वेश्चन. Just read it and just try to solve this question. Okay, what is this question is saying? Just read it. The soil profile at a construction site is shown in the figure. The groundwater table is 5 meter below the ground level at present. At present, the location of water table is this. An old well data, पुराने जमाने का जो कुएं का डेटा था, that shows that the water table was as below as 10 meter below the ground level in the past. And in the past the groundwater table in the past the groundwater table is in the past the groundwater table is basically 10 meter below the ground surface. So this is the case in the past and this is the case in present. Okay, very good. Now gamma w is equal to 9.81. He is asking the over consolidation ratio rounded off to two decimal places at the midpoint of the clay layer. What where you have to find? You have to find the over consolidation ratio at the center of the clay layer. And as we know, over consolidation ratio is equal to sigma c bar डिवाइडेड बाय सिग्मा नॉट बार. सिग्मा सी बार क्या होता है? किसी भी सॉइल ने अपनी हिस्ट्री में, अपने पास्ट में कितने स्ट्रेसेस, इफेक्टिव स्ट्रेस बर्दाश्त कर रखे हैं, डिवाइडेड बाय प्रेजेंट इफेक्टिव स्ट्रेस. सिग्मा नॉट क्या है? सिग्मा नॉट है एट प्रेजेंट उस पॉइंट पर कितने स्ट्रेसेस लग रहे हैं. इसी का रेशियो होता है आपका क्या? ओसीआर. इसी को आपको निकालना है एट द सेंटर ऑफ द क्ले लेयर. तो अगर हम सबसे पहले बेटा पास्ट की बात करें, अगर हम पास्ट की बात करेंगे, if we talk about the past, so when the water table is at 10 meter below the ground level, so it means the soil above this, the sand above this water table was 100%. The soil above this water table was 100% partially saturated. Just give me 1 second. We are trying to solve this question. Just give me 1 second. Okay. So let's try to solve this question, my dear students. Very good evening, Kaushik Kumar. So you need to find the past effective stress when the water table is here, and you need to find the effective stress at this present condition. So how you find it, just how you try to find it, just see it. How you try to find it, just fast. When it the water table is this equation, then the soil above this is partially saturated. So you have to determine the effective stress in past. So if you find the effective stress in past, how you calculate the effective stress, the total stress above the water table. So the total stress above the water table would be 17.5 multiplied by 10. It would be 17.5 multiplied by 10 plus gamma submerged. Which soil is submerged? Sand is submerged. So I will write gamma submerged of sand, multiplied by 5, plus where you need to find at the center of clay layer. The thickness of clay layer is 8 meters. So what you have to write? Gamma submerged of clay multiplied by 4. Gamma submerged of clay multiplied by 4. Then the effective stress in past is equal to 17.5 multiplied by 10 plus what is gamma submerged of sand? That is equal to 18.5 minus 9.81 multiplied by 5. Similarly, what is gamma submerged of clay? That is equal to 17 minus 9.81 multiplied by 4. So on solving this, you will get the past or the pre-consolidation pressure. It comes out to be, I'm just for your convenience, I'll just tell you the value which is coming out to be. The value is coming out to be 247.21 kilonewton per meter square. Similarly, if you try to find the value at present at the clay layer, so water table is here. So what you will write? The total stress above the water table, 17.5 multiplied by 5 plus gamma submerged 18.5 minus 9.81. How much depth of sand is submerged? It is about 10 meter. So you will multiply it with 10 meter plus gamma submerged of clay, that is 17 minus 9.81 multiplied by 4. So on calculating it, the present effective stress at the clay layer would comes out to be 243.16 kilonewton per meter square. So if I talk about the over consolidation ratio, so it would comes out to be past divided by present, 247.21 divided by 243.61. On solving, it comes out to be 1.016. As it is said that you need to answer up to 2 decimal places. So if I was in place of you, then I will write the answer at 1.02. I will write the answer as 1.02. I hope you understand that how I have calculated the over consolidation रेशियो. अगर आपको बेटा नहीं दिख रहा है तो इस तरीके से आप सॉल्यूशन जल्दी से देखकर स्क्रीनशॉट ले सकते हैं. अगर आपको बेटा नहीं दिख रहा है ना, तो आप जो है इफ यू आर नॉट एबल टू सी, तो जल्दी से बेटा इसका क्या ले सकते हैं, जल्दी से आपको जो नीचे लिखी हैं चीजें, इसका जल्दी से आप स्क्रीनशॉट ले लीजिए ताकि आपको सॉल्यूशन में दिक्कत ना आए. जल्दी से स्क्रीनशॉट ले लीजिए बेटा इसका, है ना, सो दैट वी कैन स्टार्ट. तो जल्दी से स्क्रीनशॉट ले लिया होगा आपने. चलिए जरा, आपने स्क्रीनशॉट ले लिया होगा. नाउ वी आर मूविंग टुवर्ड्स द नेक्स्ट क्वेश्चन. ओके, next question which have came in the gate examination. This is the last question of the forenoon session. It is also very easy and very important question come in the forenoon session. So what he is saying, a retaining wall of height 10 meter with a clay backfill is shown in the figure. Okay, the weight of the retaining wall is 5000 kilonewton per meter acting at 3.3 meter from the toe of the retaining wall. The interface friction between the base of the retaining wall and the base soil is delta. So your delta is given as 20 degree, and as you know the coefficient of friction is equal to mu is equal to 10 delta. The depth of the clay in front of the retaining wall is 2 meter, and the properties of clay backfill and the clay placed in place of the retaining wall are the same. दोनों clays की property same है. Assume that the tension crack is filled with the water. He is saying that the tension crack is developing, but that tension crack is filled with the water. So what he is trying to say, use Rankine earth pressure theory, take the unit weight of water, this factor of safety round off to 2 decimal places against sliding failure of the retaining wall after ignoring the passive pressure. तो बेटा अगर बेटा आपने इधर सॉइल को रोक के रखा हुआ, द टेंडेंसी ऑफ दिस सॉइल इज टू ओवरटर्न दिस सॉइल और स्लाइड दिस सॉइल. सो इस जगह पर कौन सा प्रेशर डेवलप होगा? इस जगह पे डेवलप होगा एक्टिव प्रेशर. और जब ये एक्टिव प्रेशर इधर डेवलप होगा तो वॉल इस सॉइल को दबाएगी, और जब रिटेनिंग वॉल सॉइल को दबाती है ना, बैकफिल सॉइल जब बेटा दबती है बैकफिल सॉइल, तब उस केस में कैसा प्रेशर डेवलप होता है? उस केस में उसमें डेवलप होता है पैसिव प्रेशर. और बोला गया है इसको आपको क्या करना है? इसको नेग्लेक्ट करना है. और आपको क्या करना है? फैक्टर ऑफ सेफ्टी अगेंस्ट स्लाइडिंग निकालनी है. तो फैक्टर ऑफ सेफ्टी अगेंस्ट स्लाइडिंग क्या होगी? दैट इज कॉल्ड एज रेसिस्टिंग फोर्स. हमने डैम में भी पढ़ा था. दैट इज कॉल्ड एज रेसिस्टिंग फोर्स डिवाइडेड बाय स्लाइडिंग फोर्स. Resisting force divided by sliding force. What is the resisting force? The lateral earth active earth pressure will act like this. This is nothing. This lateral earth pressure, active earth pressure will act like this. This will try to slide this retaining wall, but due to the friction between the soil, surface and this, there will be a resisting force developed that is called as friction, and its value is equal to mu into W. So resisting force will be equal to mu into W, where mu is equal to 10 of delta times of W, and where the resisting force would comes out to be W is given multiplied by 10 of delta is also given. I hope you understand resisting force. Now we will calculate the sliding force. Sliding force is nothing but the active thrust. Active thrust, how you calculate? Just think upon it. What we have to do in order to find the thrust? Just take a small element. Anywhere in the soil. Suppose I have taken a small element at a depth Z below the ground surface at this point. So just calculate the active earth pressure at this point. As we know, the active earth pressure is equal to Ka into sigma Z bar minus 2C under root of K. This is the active earth pressure. Phi is given as 0. It means Ka is equal to 1. Okay. So if I talk about the active earth pressure at ZZ layer, so it will comes out to be sigma Z bar minus 2C under root of K. Since the water table is not given, so you don't have to consider the effect of water table. So आपको इतनी बात समझ में आ गई. बहुत अच्छी बात. इस Z डेप्थ पर जब आप इफेक्टिव स्ट्रेस निकालेंगे, एक्टिव अर्थ प्रेशर निकालेंगे, तो क्या लिखेंगे? दैट वुड बी इक्वल टू गामा इंटू Z माइनस 2C. गामा इंटू Z माइनस 2C. I hope you understand. So from there, what you are getting when Z is equal to 0, active earth pressure at 0 layer is nothing but equal to minus 2C. So there can be at any Z is equal to ZC, at which active earth pressure is equal to 0. And as we know that ZC is equal to 2C upon gamma under root of K. You can easily calculate the value of ZC. So the value of ZC comes out to be 2 multiplied by C is 30. C is basically 30 and gamma is equal to 17.2. So the depth at which the active earth pressure becomes 0 is nothing but 2 into 30 divided by 17.2. So it will comes out to be 3.488 meter. This is the value of the depth at which the active earth pressure is 0. Similarly, when Z is equal to 10 meter, active earth pressure will comes out to be at 10 meter. If you put in this equation, so it will comes out to be 17.2 multiplied by 10, it will comes out to be 172. Okay, very good. Minus C is nothing equal to 30, so 2 into 30 is equal to 60. So the pressure at the base comes out to be 112 kilopascal. 112 kilopascal. So if I try to draw the active earth pressure diagram at this location, if I try to draw the active earth pressure diagram at this location, so let's see how is the shape of that active earth pressure diagram. So this is basically the reference line. As you know, at 0 level the value is 0, and at higher level the value is high. It means that this is the active earth pressure diagram. Here is negative, here is positive. But what he is saying, that the tension crack have developed. If the tension crack bacha have developed, it means that this soil zone have no contact. This soil portion have no contact, with the wall, and it does not try to do anything. ये कुछ भी करने की कोशिश नहीं करेगा. So for the active thrust you will use which diagram? For the active thrust you will use simply this diagram. This value comes out to be 10 minus, this value comes out to be 10 minus ZC. This value comes out to be Z minus Z, matlab 10 minus ZC. So if I calculate 10 minus ZC, 10 minus ZC minus 3.488, it comes out to be 6.5. It comes out to be 6.512 meter. 6.512 meter. This is the value. So by using this green diagram, you will calculate the thrust. So if I try to calculate the thrust, so value of thrust, that is PA, will be equal to 1 upon 2. What is base? Base is nothing. Base is equal to 112 multiplied by height is 6.512. Height is 6.512. On solving, tell me by the calculator what is the value of thrust. 112 divided by 2 multiplied by 6.512. The value comes out to be 364.84 kilonewton per meter. Yes or no? This is the value of the thrust. So now just use the formula. Factor of safety is equal to sliding resisting force mu into delta, that is equal to, delta is given, weight is equal to 5000, multiplied by, this first value is nothing but the 5000, this nothing but the overturning. This is nothing but the overturning. So overturning moment will be equal to 5000 multiplied by how much lever arm distance? It is nothing but it is given as I think यहाँ पर आपको नहीं दिखती होगी, दिखा देता हूँ. It is given as 3.3 meter. So it is given as 3.3 meter. So it is nothing but a resisting moment W into, this is the force, and this force is Fr is equal to 5000. We are discussing about resisting moment or overturning moment? We are discussing about the overturning moment. Overturning moment will be equal to 5000 multiplied by so 5000 multiplied by this distance. The base आपको दे रखा है? Yes, नहीं base आपको दे रखा है, नहीं दे रखा है. Wall of retaining. ओके तो ये वैल्यू हो जाएगी आपकी वेट. इसको क्या करेगा? ओवरटर्न करने की, इस तरीके से रेसिस्ट करने की कोशिश करेगा. वेट तो रेसिस्टिंग मोमेंट है. तो अगर हम बेटा ओवरटर्निंग मोमेंट निकालें, ओवरटर्न कौन करेगा? ओवरटर्न करेगा इसका पीए. तो ओवरटर्निंग मोमेंट की वैल्यू जो आएगी वो कितनी आएगी? ऊपर आएगा रेसिस्टिंग, नीचे आएगा ओवरटर्निंग. ओवरटर्निंग मोमेंट की वैल्यू आ जाएगी पीए, और ये कहां पर एक्ट करेगा? इट विल एक्ट h/3, मतलब 6.512. ये वैल्यू आएगी 6.512 डिवाइडेड बाई 3। तो ये हो गया आपका क्या, ये हो गया आपका ओवरटर्निंग। रेसिस्टिंग क्या होगा, रेसिस्टिंग होगा बेटा W इंटू 3.3। इसको रोकने की कोशिश करेगा वेट, W इंटू 3.3। वेट कितना है बेटा, वेट कितना है आपका 5000। वेट की वैल्यू है आपकी 5000 मल्टीप्लाइड बाई 3.3 मल्टीप्लाइड बाई नीचे वाला 3 ऊपर आ जाएगा, डिवाइडेड बाई एक्टिव की वैल्यू कितनी आई है 364.84 multiplied by 6.512. So the value comes out to be, the value of factor of safety comes out to be, सॉल्व कर लेते हैं, 5000 multiplied by 3.3 multiplied by 3 divided by 364.84 divided by 6.512 6.512. So the vector of safety coming out to be very high. Why? This is right. This is right. This comes out to be this. Again, solving 5000 multiplied by 3 multiplied by 3.3 divided by 364.84 and divided by 6.512. So the factor of safety in this question is coming out to be 20.3. And it means that the footing is highly safe against sliding. So you have to put the answer here, that is equal to 20 point something. So this is the all about the forenoon session. At 9 p.m. I am coming again with the afternoon session. At 9 p.m. I will again coming with the afternoon session. In that session, most new questions have been asked. If you like this video, subscribe this channel. And similarly, if you want to take the plus subscription, you can use my code that is called as ES, that is ES001. If you want to ask something related to plus or iconic subscription, so you can just search in your telegram, that is civil by Siddiqui sir. You just touch in the telegram, just search in the telegram civil by Siddiqui sir. You will get a channel named with Ehtisham Unacademy. उसको आप ज्वाइन कर सकते हैं और सारे नोट सारे डिस्कशन आपको वहीं मिलेंगे। तो 9 बजे हमारी क्लास में आप आइएगा, जहां पर हम आफ्टरनून सेशन का डिस्कशन करेंगे। क्लियर हो रही बात? चलिए, थैंक यू सो मच, बाय बाय, टेक केयर, अपना ख्याल रखिए। हम लोग मिलते हैं 9 बजे लगभग आधे घंटे के बाद। ठीक हो गई बात? चलिए, थैंक यू सो मच।